we are getting into domain and range. We have done stuff with domain and range already this year, but we're going to go a little more in depth with some domain and range of different graphs. So first of all, just a little side note. Let's remember our memory device, Dr. XY. So domain are your x's and range are your y's. So domain is the set of x's and range is the set of the y's. Dr. XY. Okay, this first picture here, this is definitely review. It wants to know what the set of ordered pairs is. So I am going to locate each point that is plotted and write down its ordered pair. So I'm going to start with the far left. And I have to count. 1, 2, 3. Ooh, I already lost it. 1, 2, 3, 4, 5, 6, 7. Okay, so -7, 1. It's kind of hard to see these. Okay, my next farthest left point is left 1, 2, 3, and up 1, 2, 3, 4. So -3, 4. My next one is, don't go left or right, so the x is 0. 1, 2, 3, 4. So 0, -4, because we dropped 4. My next point, I go right 2 to get there. I don't go up or down, so that's 2, 0. And the last one is right 1, 2, 3, 4, 5, 6. And down 1, 2, 3, 4, 5, 6, 7. So 6, -7. And since this is a set of ordered pairs, I'm going to put these little set symbols around my list of ordered pairs. I do not draw them very well, so that's as good as it gets for me. Okay, so domain, remember those are your x's. And so my x's are the first numbers in the ordered pairs. And I'm going to write them from least to greatest, which I already have them that way since I started from left to right. And if one of these x's happens to repeat, I just won't repeat it. So my set of the domain is the -7, the -3, the 0, the 2, and the 6. So your domain are your x's, the first numbers in the set of ordered pairs. Okay, my range are my y's. Those are the second numbers. And I'm going to list them from least to greatest. Now these aren't in order from least to greatest, so let's look. What's the smallest y that we have? -7. What's our next smallest y? -4. What's our next smallest y? 0. And then 1. And then 4. So we list them from least to greatest. If they happen to repeat, we wouldn't repeat them, but they didn't. Okay, this next question is review. It asks, is it a function? So we learned several ways to do this. One way was, do any of these x coordinates repeat? No, they don't. So that's one reason I know it's a function, is because my x's don't repeat. So I'm going to say that x's don't repeat. But we had a more fun way than that to tell if something was a function, and it was called the vertical line test. If I can draw a vertical line anywhere, as long as I only cross the graph once, then it's a function. Since my vertical lines never cross the graph more than once, that's another way to know that it's a function. So I could also say yes because of the vertical line test. So I'm going to go ahead and write that down too, just to review everything that we know. So if vertical lines only cross the graph once, then it's a function. Okay, this next word is going to be new to us. This function is called a discrete function. And that's because the graph consists of separate points. So what a discrete function is, it's a graph that has breaks in the graph, or holes in the graph. And so there is not a continuous graph from here to here to here connecting all of these points. There are breaks in the graph. So if you ever see breaks in the graph or holes in the graph, then we consider that to be a discrete function. Okay, the opposite of discrete is continuous. Graph number 2 is a continuous function. That's because there's no breaks in this graph whatsoever. It goes forever that way, it goes forever that way. There's no holes in the graph. It's one smooth graph. Okay, we know the line continues in both directions, so what's happening to the x values? What's happening to the y values? Well, I go forever to the right, I go forever to the left. I go forever down, I go forever up. So, what's happening to the x's? What's happening to the y's? They're going to infinity. And I'm going to make that little sideways 8 to represent the symbol infinity. They go to infinity. Okay, we have practiced this before. Since the graph goes forever to the right and forever to the left, the domain is all real numbers. Range are the y's. Since the graph goes forever down and forever up, the range is also all real numbers. And this graph has no breaks, so it is said to be continuous, which we already spoke about. And this guy is a linear function, and that's because it's a line. So remember, our linear functions are always lines. We've been working with linear functions most of the year. And so if you ever have a diagonal line, the diagonal line will always go forever to the right, forever to the left, forever down, forever up. So the domain will always be all real numbers, and the range will always be all real numbers, as long as it's a diagonal line. Because even if I drew this diagonal line in here, it goes forever left, forever right, forever down, forever up. So all diagonal lines have a domain of all reals and a range of all reals. Okay, third picture. Graph number 3 gives us part of a line or a segment. Now this one's new to us. We haven't practiced writing domain or range for a graph like this. We've only done domain and range for our separate points and also for our linear functions, whether they're diagonal lines, vertical lines, or horizontal lines. But we haven't ever done just a piece of a line called a segment. Okay, first one asks, what's the smallest value of x? Remember, your x's are what's going on left and right. So my smallest x would be this one. That's the farthest left on the x-axis, and that has a value of -4. The largest value of x would be the farthest right point, which is 1, 2, 3, 4, 5. And so you can see this graph covers all of the x's between the -4 and the 5. -4 is its farthest left, 5 is its farthest right. So the domain is the set of all x values between -4 and 5. And this is how we write it. Domain are your x's. They're between -4 and 5. You can see that they actually equal the -4 because of the closed circle, so it's going to get an equals. And then as I move to the right, my x's get bigger than -4, so I have to say my x's get bigger than -4. When I'm up here at the 5, I can't give it an equals 5 because it's an open circle. And as I move this way, my x's are getting smaller than 5. So I had to put the pointed end facing the variable, so it says the x's are smaller than 5. So this is something new to us, and we're going to be practicing this for the next couple days. Okay, next one says, what's the smallest value of y? So remember, your y's are up and down. So whenever you're looking for your range, looking for your y's, you want to look up and down. What's the lowest? What's the highest? How low? How high? So my lowest y is down here at -2. My highest y is all the way up here, which is 1, 2, 3, 4, 5, 6, 7. And so the y's go between the -2 to the +7. So my y's are between -2 and +7. Because of the closed circle at the -2, I can give it an equals. As I start moving up, 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 I'm getting bigger than -2. So I say bigger than -2. When I'm up here at my 7, it's an open circle, so no equals. And as I move down, my y's get smaller than 7, so smaller than 7. And that's what it would look like. This is considered to be a continuous graph. There are no breaks in the graph whatsoever. It starts here, it stops there, but within the graph it is one smooth motion. There's no breaks in it, there's no holes in it, so it is considered to be continuous. Okay, flip. First question, what's the smallest x value for graph number 4? So my smallest x, I would want to be looking left and right. My smallest x would happen to the left. And you can see this graph is going to go forever and forever and forever and forever and forever to the left. And if you go forever to the left, we actually call that negative infinity. My largest x value is right here. This graph doesn't go any farther right than that, and that is 1, 2, 3, 4. Okay, so I'm going to write the domain a couple of ways. I'm skipping this next section for a second. My x's go from negative infinity, to +4. They get bigger than the negative infinity, and they get smaller than the 4. And you can't actually equal negative infinity because you can't ever get to infinity. And we don't equal the 4 because of the open circle. Another way we can write this is that here my x value is 4, because that's how far right I am. And then my x's get smaller and smaller and smaller and smaller and smaller and smaller. So my x's get smaller than 4 forever and ever. That's another way of writing it. And I would be happy with either answer. Okay, let's look at our smallest y. Y, we want to look up and down because that's how the y-axis runs. So my smallest y is right here. That's how low the graph is, which is at 2. And then how high up does the graph go? The graph goes up and 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 up forever. Since the graph goes higher and higher and higher and higher and higher, it's going to positive infinity. So I'm going to write this two different ways also. So I'm going to say that my lowest y value is 2. My highest y value is positive infinity because it goes forever up and up and up and up and up. The y doesn't actually equal the 2, but it does get bigger and bigger and bigger than that. And it goes to positive infinity, so it's less than positive infinity, but it can't equal it because you can't ever reach it. Okay, let me write that a different way. Here my y value is 2, and my y gets bigger and bigger and bigger and bigger because it's going up and up and up. So my y starts at 2, gets bigger and bigger and bigger, so we say y greater than 2. This is also considered to be a continuous graph. It has a start, and it goes forever and forever and ever. There's no holes in the graph. There's no breaks in the graph. It's one smooth graph. Okay, number 5. This looks like a piece of a quadratic. We've been looking at quadratics the last couple days because it looks like a parabola. You just don't see an entire parabola that goes forever and ever. So the smallest x value, Remember x, I'm looking left and right because that's how the x-axis runs. So how far left, how far right? So how far left? 1, 2, 3, 4, 5. -5 is how far left it goes. And how far right does it go? Right there at the 3. So that's how far left and that's how far right. Let's go ahead and write our domain. So my x's are between -5 and +3. They actually equal the -5 because of the closed circle. They actually equal the 3 because of the closed circle. So when I'm here at my -5, as I start moving to the right, are my x's getting bigger or smaller? My x's are getting bigger because I'm going more and more and more to the right. So they're getting bigger than -5. When I'm here at my 3 and I travel to the left, are my x's getting bigger or smaller? They're getting smaller because I'm going more and more left. So they're getting smaller than 3. Okay, what is my smallest y value? So y's, I'm looking up and down because that's how the y-axis runs. So I want to know how low, how high is the graph? How low, how high? This is the lowest point, and what's my y right there? -3. My highest y is all the way up here, and how high is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. So my y's are going between -3 and +9. Down here at the -3, it equals it because of the closed circle. All the way up here at 9, it does equal it. It does get all the way up there. So let's talk about what happens. When my y is down here at the -3, as I start moving up, are my y's getting bigger than -3 or smaller? Bigger than -3. When I'm all the way up here, when my y is 9, if I go this way or if I go this way, do my y's get bigger than 9 or smaller than 9? The y's get smaller than 9. So it looks like that. This is also considered to be continuous. The graph has one smooth motion. It has a start, it has a stop. There's no holes in the graph. There's no breaks in the graph. It's one smooth motion. Okay, number 6. This is another quadratic. I'm going to go ahead and just write quadratic on 5 and 6. These are our parabolas, our U-shaped graphs. So these are our quadratic functions. Okay, domain, remember, I'm thinking about x's. Range, I'm thinking about y's. So my x's, do I go forever to the left? Do I go forever to the right? I sure do. It goes forever to the left, forever to the right, so the domain is all real numbers. Let's talk about an upside down parabola for a second. Does this graph go forever to the left, forever to the right? Yes. So its domain would be all real numbers too. So no matter whether the parabola opens upward or opens downward, they both go forever left, forever right. Forever left, forever right. So they both have domain of all real numbers. Now range are your y's, and we're looking up and down. Does this graph go forever up and forever down? No, it just goes forever up. So I need to know where my y starts. And my y starts at -1, and then it goes up, 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 up. So my y's start at -1, and they get bigger and bigger. And of course, I could write this a different way, kind of like how I did on number 4. But I think this is really good right here. And this is considered to be a continuous graph because it has a starting and it goes forever and ever and ever up. There's no holes or no breaks in the graph whatsoever. Okay, number 7. I just kind of have to know what this graph looks like. Is this linear or is this quadratic? It's linear. It's going to graph a line. Okay, and everybody should have an idea of what this looks like, but I'm actually just going to grab a calculator and I'm going to show you. So if I want to graph y equals 5x, I just went to my y equals on the calculator, I put in 5x, and let me just show you a picture. Okay, domain are x's, left and right. Does this graph go forever to the left, forever to the right? Yep, so domain is all real numbers. Kind of talked about that earlier. Range or y's, does the graph go forever down, forever up? Yep, so range is all real numbers too. And this is considered to be a continuous graph. It doesn't have any holes or breaks. It's just one smooth motion. Okay, number 8. This one causes us to think a little bit more. It says, Greg received a $15 gift card to download music for his MP3 player. Each song costs $1.50. Okay, I'm going to write an equation for this, and then we'll talk about it. And I'm going to graph it too, so I'm going to use y and x when I write my equation. So y is going to stand for his money that he has. He starts with a $15 gift card, so that's how much money he has to begin with on this card. And then each song costs $1.50. So if he starts buying music, will he be adding to his $15 or taking away? He'll be taking away, and he's taking away $1.50 every song. So X is representing the number of songs. Okay, so this time my domain and my range have to make sense according to the situation. I know this is a linear equation, which if I just graphed it and it had no meaning, I know that because it has negative slope, it would be a line that goes like this, which looks like it goes forever left, forever right, forever up, forever down. So domain and range would be all reals. But I can't do that because this problem has meaning to us. It's talking about certain things. We start with $15 to use, and we're taking away $1.50 for every song. So let's just stop and think about this for a minute. Domain are your X's, and let's think about the number of songs that we could buy. Can we buy a negative number of songs? No. Can we buy 0 songs? Yes. How many songs can we buy if we only have $15? How many songs can you buy if you only have $15? And I'm just showing you here that if each song is $1.50, I can buy 10 songs, and that uses up all $15. So my domain, my X's, I can buy 0 songs all the way up to 10 songs. So I can actually equal the 10 and equal the 0. I can buy more than 0 songs, but I have to buy less than 10 songs. And this is what makes sense according to the problem. You can't buy a negative number of songs, and you can't buy more than 10 songs because you only have $15. Okay, let's talk range. Range are our Y's. It's how much money do we have. So do we have a negative amount of money in this situation? No. What amount of money do we start with? We start with $15. And if we can't have a negative amount of money, can we have $0? Yes. So our money can go from $0 all the way up to 15, because that's the maximum that our card held. And we can drain it. We can go to 0. So we can equal the 0, we can equal the 15. We can have more than $0, but we can't have more than 15, so it has to be less than 15. And that would be the domain and range that makes sense for this problem. Thank you so much. Smiley face.